Hi everyone, welcome to lecture 9 of Technical Mathematics. In this lecture, we are going to discuss few problems related to binomial theorem. The theory part corresponding to these problems were discussed in our previous lectures. If you are not familiar to binomial theorem, then I recommend you to watch lectures 7 and 8 and then attempt problems given in this lecture. I have included links to those lectures in the description of this video. Now, most of the problems given in this lecture are taken from various competitive exams and it includes previous year Kerala PSC exam questions. I encourage you to attempt problems by your own and then check the solution given in the video. So, let's get started. Problem number 1. If n is an even natural number, then middle term in the expansion of x plus 1 by x whole raised to n is. So we are asked to find out the middle term in the expansion x plus 1 by x whole raised to n. So we know that in the expansion a plus b whole raised to n, we are having n plus 1 terms. N plus 1 terms. And the middle term in the expansion will be n by 2 plus 1th term. N by 2 plus 1th term if n is even. Okay, so here in the question it is given that n is an even natural number. So therefore the middle term will be n by 2 plus 1th term. And we know the expression of the rth term in the expansion a plus b whole raised to n. The rth term in the expansion a plus b whole raised to n is nc r minus 1 a raised to n minus r minus 1 into b raised to r minus 1. So this is the rth term. And we are asked to find out the middle term, which is n by 2 plus 1th term. So therefore the n by 2 plus 1th term will be nc. In place of r we have to consider n by 2 plus 1. So nc r minus 1, its equivalent version will be n by 2 plus 1 minus 1. So that is n by 2. Okay, so nc n by 2. In place of a, what we have here is x. So x raised to n minus r minus 1. So in this case, in place of r, what we have is n by 2 plus 1. So n by 2 plus 1 minus 1. So that will be n by 2 itself. So here we will have n by 2. Then b raised to r minus 1. In place of b, what we have is 1 by x. So 1 by x raised to r minus 1. In place of r we have n by 2 plus 1. So n by 2 plus 1 minus 1, that is n by 2 itself. So this will be the n by 2 plus 1th term in the expansion x plus 1 by x whole raised to n. So let's simplify this. So this will be equal to nc n by 2 x raised to n minus n by 2 will be n by 2 itself. Then we have 1 by x raised to n by 2. Okay, so here these two terms will cancel and it will result in a value which is equal to 1. So here the final result is nc n by 2. So this is the middle term in the expansion x plus 1 by x whole raised to n. Now let's see what is the expansion of nc n by 2. So nc n by 2 will be equal to n factorial divided by n minus n by 2 factorial into n by 2 factorial. So that will result in n factorial divided by n minus n by 2, that will be n by 2 itself. So n by 2 factorial into n by 2 factorial. Okay, so here the final answer is n factorial divided by n by 2 factorial whole raised to 2. So that is given by option B, n factorial divided by n by 2 factorial whole raised to 2. So answer is given by option B. Okay, problem number 2. nc naught plus 2 into nc1 plus 3 into nc2 plus etc. plus n plus 1 into ncn is equal to. Okay, this one is similar to an identity. Okay, you may learn this by heart. Here this expression may be rewritten as 1 into nc naught plus 2 into nc1 plus 3 into nc2 plus etc. plus n plus 1 into ncn. Okay, so here you can see that along with the binomial coefficients nc0, nc2, etc., we are having one constant term. So it begins in the first term it is 1, in the second term it is 2, and in the third term it is 3. Likewise it proceeds up to the n plus 1th term. In the n plus 1th term the constant is n plus 1. Okay, so this will be equal to n plus 2 into 2 raised to n minus 1. So this is the answer, so which is given by option B. So here the right answer is option B, n plus 2 into 2 raised to n minus 1. So you may remember this as an identity. Okay, now let's move on to problem number 3. nc1 minus nc2 plus nc3 minus etc. plus minus 1 whole raised to n ncn is equal to. Okay, we are given 4 options, we have to find out the right answer. Okay, so this one is derived from an identity. Okay, that is nc0 minus nc1 plus nc2 minus nc3 plus etc. plus minus 1 raised to n ncn is equal to. Okay, we have learned this identity. The value of this expression will be equal to 0. Okay, now if we take this first term to the right hand side, what we get is minus nc1 plus nc2 minus nc3 plus etc. plus minus 1 whole raised to n into ncn equal to, when this plus nc0 comes on right hand side, it becomes minus nc0. Okay, now just multiply both the left hand side and right hand side with minus 1. What we get on left hand side will be nc1 minus nc2 plus nc3 minus etc. up to minus 1 whole raised to n into ncn, and this will be equal to plus nc0. Okay, and nc0 value will be equal to 1. Okay, so here in the question the expression given is what we have here on left hand side. Okay, and the value of this expression will be equal to 1. Okay, so here the right answer is given by option D, that is 1. Okay, now let's proceed to problem number 4. Now the coefficient of middle term in the expansion of x minus x cube by 5 whole raised to 8 is equal to. So we are asked to find out coefficient of the middle term. So here the value of n is 8, which is an even number. So therefore the middle term will be n by 2 plus 1th term. That will be the middle term. So that is 8 by 2 plus 1th term. So that will be nothing but 8 by 2 is 4, 4 plus 1, that is 5. So it is the 5th term which comes as the middle term in this expansion. Okay, now the coefficient or the middle term itself, the 5th term will be 8c 5 minus 1, that is 4, into x raised to 8 minus 5 minus 1, that is 4, into x cube by 5 whole raised to 5 minus 1, that is 4. So this will be the 5th term, which will be equal to 8 into 7 into 6 into 5 divided by 1 into 2 into 3 into 4 into x raised to 4 into x cube by 5 whole raised to 4. Okay, now here we may simplify this. 2 into 3 is 6, so this 6 and this 6 can be cancelled. Now here we have 4, 8 by 4 will be 2, so we are having 70 into x raised to 4 into, here we have x term as well as a constant term. 1 by 5 is constant, so that we may take outside. So x cube raised to 4 into 1 by 5 raised to 4. Okay, so if we simplify this, what we get will be, here we have 5 raised to 4 in the denominator. So 70 by 5 raised to 4 into x raised to 4 into x raised to 12. Okay, so this will be equal to, here we have 70, so 1 5 can be cancelled. So if we cancel that, we get 1 4 divided by 5 cube, that is 125 into x raised to 16. So this will be the fifth term in the expansion. So here coefficient is nothing but 14 by 125. So the answer is given by option C, 14 by 125. Okay. Problem number 5. In the expansion of x plus 5 whole raised to 13, the coefficients of third term and dash terms are equal. Okay, so we are asked to find out the coefficient of the term which has a coefficient value equal to that of the third term. Okay, so let's see what is the third term in the expansion. The third term in the expansion will be 13c to x raised to 13 minus 3 minus 1. So that will be 13 minus 2 into y raised to 3 minus 1, that is 2. Okay, so it is 13c to x raised to 11 into y raised to 2. That comes as the third term in the expansion. Now the coefficient is 13c2. The coefficient of third term is 13c2. This will be equal to coefficient of the, say, some term, that is, let's take it as rth term. So the rth term in the expansion will have a coefficient which is 13c r minus 1. Okay, so we have studied the formula. NCR1 will be equal to NCR2 if R1 plus R2 is equal to N. Okay, so here N value is 13. In place of R1 we have 2, and in place of R2 we have R minus 1. So let's equate these two R values in here. Say 2 plus R minus 1 should be equal to 13. So if these two combination values has to be equal, then 2 plus R minus 1 should be equal to 13 as per this formula. Okay, so if you simplify this, we will get the value of R. So here it will be, if we take the constant terms to the right hand side, what we get on left hand side will be R equal to, okay, 2 minus 1, that is plus 1. When you take that to the right side, it will become minus, so 13 minus 1 will be 12. Okay, so the 12th term will have a coefficient which will be equal to that of the third term. So here answer is given by option A, that is 12. Okay. Problem number 6. In the expansion of x minus 5 whole raised to 10, coefficient of x raised to 7 y raised to 3 minus coefficient of x raised to 3 y raised to 7 is equal to. So we are asked to find out the difference between two coefficients. Okay, now here the rth term in the expansion, will be minus 1 raised to r minus 1, 10c r minus 1 x raised to 10 minus r minus 1 into y raised to r minus 1. So this will be the rth term in the expansion. Now let's try to find out which term has x raised to 7 y raised to 3. So if the term is having x raised to 7 y raised to 3, then the value of r minus 1 is equal to 3 for that term. Okay, so here in general expression the power of y is r minus 1. In this term, what we have here, we have power of y as 3. So r minus 1 is equal to 3 for this term. So if r minus 1 is equal to 3, then the value of r is 4. So the fourth term will have x raised to 7 y raised to 3. Similarly, the term having x raised to 3 y raised to 7 will be, let's calculate that, x raised to 3 y raised to 7. Here the value of r minus 1 is 7. So it indicates that r is equal to 8. Okay, so it is the 8th term that has x raised to 3 into y raised to 7. Okay, so here let's see what will be the fourth term. Fourth term in the expansion. As per this formula, it will be minus 1 raised to 4 minus 1, that is 3 into 10c r minus 1. So 10c 4 minus 1, that is 10c 3 into x raised to 10 minus 4 minus 1. So that will be 3. 10 minus 3, that is 7. So x raised to 7 into y raised to 4 minus 1, that is 3. So fourth term will be minus 1 raised to 3 into 10c3 into x raised to 7 y raised to 3. Okay, now the eighth term in the expansion will be minus 1 raised to 8 minus 1, that is 7 into 10c 8 minus 1, that is 7, 10c 7 into x raised to 10 minus 7, that will be 3 into y raised to 7. Okay, so this will be the eighth term in the expansion. So here we can see the two coefficients. This is the coefficient of the fourth term and this is the coefficient of the eighth term. So let's find out the difference between two. Minus 1 raised to 3 into 10c3 minus 1 raised to 7 into 10c7. So here we have minus 1 raised to 3, so that will be minus 1 into 10c3. So that will be minus 10c3 minus, here we have minus 1 raised to 7, so that will be minus 1 itself. So that minus and this minus will get nullified. So we have plus here, plus 10c7. Okay, and the value of 10c7 will be equal to 10c3 itself, because 3 plus 7 is equal to 10. Therefore 10c3 will be equal to 10c7, and therefore 10c7 we may replace as 10c3. Okay, so we may replace this 10c7 with 10c3 itself. Okay, so now what we get here is minus 10c3 plus 10c3, so the value will be 0. Okay, so the difference between the two coefficients will be 0. So that is given by option D, and therefore the right answer is option D. Okay, now let's see problem number 7. The coefficient of x raised to 5 in the expansion of x plus 3 whole raised to 8 is. Okay, so in the expansion, the rth term in the expansion will be 8c r minus 1 x raised to 8 minus r minus 1 into 3 raised to r minus 1. Okay, now here if the term is having x raised to 5, it means that the value of 8 minus r minus 1 should be equal to 5. Now from this we can calculate the value of r. So 8 minus 5 will be equal to r minus 1, and this implies that we have 3 here, 8 minus 5, 3 equal to r minus 1. So this implies that r value is 4. So it is the fourth term in the expansion which has got x raised to 5. So let's see what will be the fourth term. Fourth term in the expansion will be, okay, let's derive the fourth term expression from this general expression. So it will be 8c, r value if it is 4, what we get is 4 minus 1, 3 here, 8c3 x raised to 8 minus 4 minus 1, 4 minus 1 is 3, so 8 minus 3 we get 5 here, x raised to 5 into 3 raised to 4 minus 1, so that will be 3. So this is the fourth term, 8c3 into x raised to 5 into 3 raised to 3. So here the coefficient of x raised to 5 is 8c3 into 3 raised to 3. Okay, so the fourth term will be this one. Okay, 8c3 into 3 raised to 3 into x raised to 5. So here the coefficient of x raised to 5 is this one, 8c3 into 3 raised to 3. Okay, so let's see what is 8c3 into 3 raised to 3. that will be equal to 8c3 will be 8 into 7 into 6 divided by 1 into 2 into 3, that into 3 raised to 3. Okay, so let's cancel 1 3, so we get it as 3 raised to 2. Then we have 2 here, 2 and this 6, when we cancel we get another 3. So what we get is 8 into 7 into 3 into 3 raised to 2 is 9, so into 9. Okay, so when you calculate this we get it as 1512. Okay, so here the right answer is given by option C, that is 1512. Okay, now let's see few results related to binomial theorem. X plus y whole raised to n plus x minus y whole raised to n is equal to 2 into nc naught x raised to n y raised to 0 plus nc2 x raised to n minus 2 y raised to 2 plus nc4 x raised to n minus 4 y raised to 4 plus etc. plus n by 2 plus 1th term. So the peculiarity here is that you may see that all r terms are even numbers. Okay, here we have 0, here we have 2, here we have 4, these are even numbers. Okay, so when plus comes here we have even numbers, so it is 2 into nc naught x raised to n y raised to 0 plus nc2 x raised to n minus 2 y raised to 2 plus etc. Okay, and the number of terms in this expansion will be n by 2 plus 1. So here this bracket represents the rounding function. Okay, now the second result says x plus y whole raised to n minus x minus y whole raised to n is equal to 2 into nc1 x raised to n minus 1 y raised to 1 plus nc3 x raised to n minus 3 y raised to 3 plus nc5 x raised to n minus 5 y raised to 5 plus etc. plus n plus 1 by 2th term. Okay, here also this represents the rounding function. Okay, so here we have minus sign in between these two expansions. So what we get is 2 into, here you may see that all r terms are odd numbers, c1, nc3, nc5, likewise we are having odd terms. So when minus comes in between, we will be having odd r values in the combination coefficients. Okay, now let's see few problems related to these two results. Now let's see problem number 8. Root 2 plus 1 whole raised to 5 plus root 2 minus 1 whole raised to 5 is equal to. So this problem is based on the result what we just discussed. So it is in the form x plus y whole raised to n plus x minus y whole raised to n equal to this one. Okay, so when we have plus here, we will be having n by 2 plus 1 terms in the expansion. Okay, so let's see that first. So here we are having plus, so this expression's expansion will be having n by 2, this is a rounding of function, n by 2 plus 1 terms. Okay, it will have that many terms, n by 2 plus 1 terms. So here value of n is 5. So this implies that we will be having 5 by 2 plus 1 terms. Okay, so 5 by 2 is 2.5, and when you round that to the nearest integer we get 2. So it is 2 plus 1 equal to 3. So we will be having 3 terms in the expansion. Okay, and now let's see what will be the expansion. So we have to use the formula what we just discussed, 2 into nc naught into x raised to n into y raised to 0 plus nc2 x raised to n minus 2 into y raised to 2 plus etc. Okay, so let's expand based on that equation. So root 2 plus 1 whole raised to 5 plus root 2 minus 1 whole raised to 5 will be equal to 2 into n value is 5, so 5 c naught root 2 raised to 5 into 1 raised to 0 plus 5c2 into root 2 raised to 5 minus 2 into 1 raised to 2 plus 5c4 into root 2 raised to 5 minus 4 into 1 raised to 4. So we have 3 terms here. So number of terms is 3. So we may close the bracket. Okay. So this will be the expansion corresponding to this one. Okay. So now let's try to simplify. So this will be equal to 2 into 5c0. 5c0 will be 1. So 1 into root 2 raised to 5. So that will be equal to 4 root 2. Okay. Plus, okay, here we have 1 raised to 0, that is 1. Okay, then plus 5c2. So 5c2 will be 5 into 4 divided by 1 into 2. Okay. Then root 2 raised to 5 minus 2. So 5 minus 2 will be 3. So root 2 raised to 3. So that will be equal to 2 root 2 plus, here we have 1 square. So that will be 1. Then plus 5c4. 5c4 will be 5 divided by 1. Okay. So that will be 5. 5 into root 2 raised to 5 minus 4. So that is root 2 raised to 1. So that will be root 2 then into 1. Okay. Now let's try to simplify. So here we have 2 and that 2 and this 2 will be getting cancelled. Okay. So we have 2 into 4 root 2 plus, here we have 5 into 4, that is 20 root 2. Okay. Plus here we have 5 root 2. 5 root 2. Okay. So when you add all these things, we will get it as 2 into 4 plus 20, 24 plus 5, 29 root 2. 29 root 2 into 2. So that will be equal to 29 into 2, that is 58. 58 into root 2. Okay. So that will be the answer. So here option B gives the right answer. So option B is the right choice. Okay. Now let's see problem number 9. The expansion of x plus root over x cube minus 1 whole raised to 5 plus x minus root over x cube minus 1 whole raised to 5 is a polynomial of degree. So we have to find out the degree of the polynomial once we expand this expression. Okay. So here this expression is in the form x plus y whole raised to n plus x minus y whole raised to n. So as we discussed in the last problem, this expansion will have 5 by 2 plus 1 terms. 5 by 2 plus 1 terms. So that is 2.5 rounded off plus 1. So that is 2 plus 1 or 3 terms. Okay. And the expansion will be 2 into nc0. Here n value is 5. So 5c0 into x raised to 5 into root over x cube minus 1 whole raised to 0 plus 5c2 x raised to 5 minus 2 root over x cube minus 1 whole square plus 5c4 x raised to 5 minus 4 root over x cube minus 1 whole raised to 4. Okay. So we are having 3 terms. So we have written 3 terms here. So we may close the bracket. So this will be the expansion corresponding to this one. Okay. Now let's try to simplify. So this can be written as 2 into 5c0 is 1. So 1 into x raised to 5 into, here we have root over x cube minus 1 whole raised to 0. So that will be 1 again. Now plus 5c2, that will be 5 into 4 divided by 1 into 2. Then that into x raised to 5 minus 2. So that is x raised to 3. So x raised to 3 comes here. Then root over x cube minus 1 whole square. So that will be x cube minus 1. Okay. So this will be the second term plus Then we have 5c4. 5c4 value will be 5 divided by 1. Then x raised to 5 minus 4. So that is x raised to 1. Then that into root over x cube minus 1 whole raised to 4. So that will give us x cube minus 1 whole square. Okay. Now let's try to simplify this. Here we have x raised to 5. So this can be rewritten as 2 into x raised to 5 plus this will be 4 and 2 gets cancelled. So here we will get 2. So 5 into 2, that is 10 into x cube minus 1 plus 5 by 1, 5 into x cube minus 1 whole square. Okay, so here the highest degree will be nothing but that appears here. Okay, so we have x into x cube minus 1 whole square. So when you expand x cube minus 1 whole square, you will be getting x raised to 6 as the first term. When you multiply that x raised to 6 with this x, you will be getting x raised to 7. So 7 will be the highest degree in this expansion. So therefore degree of the polynomial will be nothing but 7. 7 will be the degree of this polynomial. Okay, so here the right answer is given by option C, that is 7. Now let's see question number 10. The expansion 1 plus root 2x whole raised to 9 plus 1 minus root 2x whole raised to 9 have dash terms. So here the question is to calculate the number of terms. So this expansion or this expression is in the form x plus y whole raised to n plus x minus y whole raised to n. So this will have n by 2 plus 1 terms, n by 2 plus 1 terms. Okay, so here n value is 9. Okay, so therefore it will have 9 by 2, okay, rounded off to the nearest integer plus 1, that many number of terms. Okay, so that will be, so 9 by 2 is 4.5. When we round off that to the nearest integer, we get 4. 4 plus 1 is equal to 5. So it will have 5 terms in the expansion. Okay, so here the right answer is given by option A, that is 5. Okay, so with this we are coming to end of lecture 9. In lecture 10 we will continue with binomial theorem. We will discuss another set of important questions from binomial theorem. So for upcoming videos you may subscribe to our YouTube channel Vadhyar Online Academy, and for study materials you may subscribe our Telegram channel using this link. So see you in lecture 10. Goodbye.